Good morning. I'm Marianne Kelso from Olympic College in Bremerton, Washington, and I'm full-time math professor at Olympic College, and I'm working on a project with computational class notes to put college algebra online using a hybrid course model. And we're using Mathematica, Wolfram Mathematica, to program the book I wrote. So it's an ebook, and it'll all be available on the internet. Okay, good afternoon. My name is Marianne Kelso, and I'm a full-time math faculty at Olympic College in Bremerton, Washington, which is west of Seattle. And yes, there is something west of Seattle. Several people have said, no, there's nothing west of Seattle. Seattle's on the coast. Well, Seattle isn't on the coast. It's on the Puget Sound. So this is a picture of one of the buildings and the plaza out in front, which is, I think, really quite remarkable. And I'm partnering with Computational Class Notes to do this project I'm working on. So both logos will be scattered throughout the presentation. You might ask, how did I get started with computational, or why do I pair? I won't tell you how I got started with them, but why am I paired with computational class notes? And I haven't programmed since the early 90s, and in the early 90s I programmed with Fortran 77. So I do understand programming, but it's been a long time. So I wrote a college algebra textbook, and they're the ones that are programming it for me. So, let's see if I got everything. I've, like Marianne here in the front row, both of us did our first lines of Mathematica code Tuesday at the class that they taught before we started the conference. Okay, so cloud power, so I've shortened the name of the topic to Cloud-Powered Mathematics, a computational foundation for student success. Okay. Albert Einstein said, education is not the learning of facts, but the training of the mind. Often our education is the learning of facts rather than training our minds how to think. We, at Olympic College and Computational Class Notes, are interested in the training of the mind. Okay, so we have some common goals. We want to make sure students learn math, but we want to have them remember what they learned. Okay, and we don't think students should have to pay publishers' shareholder dividends. So we're trying to put publishers out of business. And we know that the more active practice students have, the more they learn. It's a little like trying to learn how to swim. You can't learn how to swim unless you put your face in the water and actually move your arms and legs. So with math, it's kind of the same thing. We want them to experiment. We want them to do some computation, perhaps with pencil and paper, and sometimes just in your head. We want them to learn how to graph. And then there will be exercises, which include homework. And in any community college, you got to have assessment. So Wolfram Mathematica helps bring concepts alive through visualization. And students are going to use ordinary technology devices instead of textbooks. Ordinary tech devices are usually much cheaper than even one textbook. Course content will be available everywhere Wi-Fi is, so you can do your homework at home or at the local Starbucks or wherever you are. And accessibility is built in as we work through this, and by that I mean the American for Disabilities Act in terms of accessibility. Okay, so a friend of mine said this. I've been told this a lot when I was working through the education system, that kiddish maths, I mean like children's math, requires kiddish tech. So you don't have to have high-tech things for the little kids. But you know, little kids' stuff probably requires the most advanced techs. and often more advanced than college-level mathematics. Sometimes in college-level mathematics, we're so self-motivated and self-disciplined that we can take care of ourselves, whereas K through 12 sometimes needs more work. So C, CN, and I hope to lead college algebra using the Wolfram Cloud and Mathematica with the actual online books ready by 2017. So what are we going to do with this program? We're going to reduce cost to students. As the cost of smartphones decreases, maybe to less than $20, they can become almost disposable. If it breaks, then you can buy another one. And they can become an educational tool for use in these modules. As you're going through a lesson, you get a whole screen of exercises, or examples, I mean, and if you refresh, you get a whole screen of different examples. So there's almost unlimited supply of examples for students instead of the static 4 to 6 that are given in a hard-covered book, hardbound book. And this is going to eliminate the need for updates, which means the publisher after 3 or 4 years says, well, we have to update, besides we're not getting any income because the bookstores are getting all the resale income and we're not selling any new books. So, but we don't have that problem. We can update sort of on the fly online. So that brings us to a question. Can topics in math be approached in a manner similar to topics in physics and chemistry? Sort of an investigative approach. Can we do that? This means, if we can do this, this means that instructors, professors, teachers are going to have to give students back the power over their own learning. I'm going to have to stop being the sage on the stage, if you will, which is going to challenge a lot of us because we like that role. And can we use the tremendous power of modern computers and Wolfram Mathematica to provide an abundance of experiments to students? I only hope so. So why have computers if we don't use their magnificent power? So the students are going to manipulate an almost unending stream of examples, and then they will help the professor define and generalize a concept. We're not going to give you y equals mx plus b and think you should, in a rote manner, work with it. We want you to see some things, play with some things, and then we will work it out together. Yeah, this is going to be hard for me too. Okay, so we're going to look at 3 topics. I don't think we're probably going to get through all 3, but I'm prepared for 3, and then we'll see what happens. I'm very adamant about keeping to the 30 minutes that were allotted. So my presentation is supposed to last 20, and then you have questions, and then there's 5 minutes for moving to the next place. Okay. Why is any math topic an issue for students? Well, for part of it is we've been conditioned, especially we as women. Oh, you don't need to be good in math. You're just going to, get married and have babies. That's the story I was told. So I don't know if they're still telling that story or not, but that's the story I was told. So I didn't have to be good at math. I was, but that's not important. Sometimes books are a little challenging for our students. They are not able to adapt to new methods of learning. If a school district adopts a math textbook, they probably keep it for 10 years. And that's a long time, especially now as the technology is changing so quickly. So how do we find a solution? I don't know. I'm constrained at my community college to teach a certain library of concepts, so I don't have a lot of freedom to move however I want to. But the solution I'm trying for the pilot in January will be a hybrid course, and students will not be required to attend class every day. They will have to come to class the first week, and then any time after that when there's a scheduled exam or quiz, because if Johnny is enrolled in the class, I don't want his Uncle John taking the quizzes. So you'll have, they'll have to come partly. There's always a cohort of students who like to be in class. They like to have the class there. Some of us need some outside discipline imposed upon us. And if I make myself come to class, then I'll probably actually study for that hour while I should be in class. So that's what I'm developing right now. Okay. And for those who come to class, there will be an opportunity for more individual instruction or for more questions to be answered from me, rather than if I'm teaching, the sage on the stage thing for maybe 20 or 30 minutes and then worksheets or homework or what have you. So it's going to be a huge mindset change for me, but I think I'm getting there. Okay. And you say, well, I don't know how we're going to do this. Well, at Olympic College, I have a math colleague who tracks success in all of our math courses. So he can take my students from these two, I have two sections of college algebra, and he will track them from when they leave my class through any other math classes they take, through graduation. And if they go to school at a state institution in Washington, they can be tracked through there too. So we have a good system to track and see which programs. But it takes a while for students to work through all those steps. Okay? So how does this solution help a student obtain results? So so we're going to start by modeling linear functions. And it's a pretty simple concept, but a lot of students have trouble with the slope part and the y-intercept part. Okay. So at Olympic College, in Pre-Calc 1, college algebra, students do review linear functions and their applications prior to moving on to polynomials of higher degree. Okay, so students sometimes recognize linear functions from the rote learning in a pre-college level class. Some have seen the y equals mx plus b part, but some have not seen the function notation. So we're putting both notations in the lessons. So here we go. So through a dynamic module, we're going to provide students with an almost unlimited supply of experiments, which will help them visualize what is happening when dealing with linear functions. So they'll get a visual understanding and intuitive understanding, we hope. They will do some calculations, so visually, intuitively, and calculationally, they should get, that gives us a whole comprehensive package for our students. Visually, they have, I'll show you, I have some modules that do the visual, which will help with more intuitive when they're looking to calculate slope and intercept. Okay, so that's the bulk of my presentation. So now I'm going to look at some examples. And this first one has to do with linear functions. And this is where, when I was practicing in the ready room, things got a little bit dicey, but we'll see what happens. Aha! Okay. So here is here is an example. And that's not on my desktop. But notice that the y-intercept stays the same. And as the slope changes, the magenta dot stays on the line in the first window. And we can watch the slope changing from positive to negative. And the number is getting closer and closer to 0. In the second window, we see all the points that are less than. And notice that we see the less than in the y in that first inequality there. And then in the third window, again, we have the magenta dot that stays in the greater than window. So they can play with this. And let's see, you've got, okay, I've got to look over here to use my mouse. Is that the same? Was the y-intercept 6 before? I can't remember. Let's try another one. We must not be hooked up to the internet. Because it looks to me like the same one keeps coming up.
Are you hardwired in, and is your Wi-Fi off? Are you hardwired into the internet with the Ethernet cable?
It looks like the Wi-Fi is off on my desktop.
It should be. Do you have the Ethernet cable connected?
Is that this one? I don't know. But I think we'll see as we go if there's another problem as we move through. When I get my phone on, I think you'll see.
I don't know that you're connected to the.
I don't know either. But anyway, that's one of the first things they see. And then we go to this one. Whoops. Okay, this is another one, only this time it's a little bit faster. We made it slow the first time so students would get a better sense of, but this was, it's going to push them a little harder. And what I like about this is that all the slopes are not integer values. And all the y values are not integer values. Students get to the point where they think all values when you're in a math class should be integers. And that's an ugly number. 5 247ths is an ugly number. And I just say, no, that's my favorite number. And they look at me and roll their eyes, like my kids used to do. So, okay, so the y-intercept is at -7. It changed this time. There must have been something wrong with the other link, so I'm not going to worry about it. But you get the sense of what's happening here, don't you? Mm-hmm. And there's, on and on and on. We can make as many of these as we want. Okay. And then this one, again, gives y equals mx plus b, but I'm probably going to have to give a short lecture before we get to this module to tell that, because they haven't seen the delta y over delta x notation yet. They've seen the y2 minus y1 over x2 minus x1 in previous classes. So we're going to have to talk about those two values and where they come that's where the change in y over the change in x comes from. And I like the delta symbolism because it does start getting them into thinking about change as a delta, a change in delta. So anyway, and again, notice we don't have any, we don't have many integers here with our 2 y values and our 2 x values. So I think at this point, they would probably have to use their calculator. But if you look at the far right ratio over here, if you think about that in terms of approximate values, you know that -24 divided by +6 is going to give you a -4. So it should help them with their checking to see if their numbers make sense. Because students don't always do that. They don't always check to see if their numbers make sense. Okay. So in this page, we have the same linear function, but we have 3 different sets of arbitrary points. and a different slope value, the one of -6. And is that a +8 over there? I can't, yeah, which is a different y-intercept. 2 points, 2 points, 2 points. So, okay, so let's close that. And then from my desktop, I'm hoping I can do this. Where is there it is. Okay. There we go. I want to minimize this. Okay, now I can bring it back here on my desktop. Just in case your mother ever says that this is too hard for old women to learn, you can always use a different example. I graduated from college in '92. I'm a late bloomer. Okay, so here's another kind of thing that we use. Notice in this example we have sliders. So they can learn to move the slider back and forth, and they don't have to program it. They can also recognize, that if you click on the plus sign, that you can enter a particular value. And 0 is boring, so. And then use the slider the way we all do with a step backwards, play, step forward, faster forward, slower forward, and then forward. So we can change the slope, we can change the y-intercept, and we can change the number of dots in the spray. This particular one goes from 50 up to 400. So they really get a visual of what's going on. Okay, so then for what it's worth, I failed physics. But here's a physics application with, look at all the sliders and the graph that's been generated with the position vector, the velocity vector, and the acceleration vector. And this, as we've seen in other presentations, we can move around. We can change the slider, look at time, and watch that time vector go along the curve. So there's a lot of things available for us here using these. Here's an example of a quiz, and this is from Ryerson University in Toronto. So I'm just going to pick arbitrarily what's going on here. Now I'm going to leave the last one blank, submit it, and it doesn't submit. Look what it tells you. It tells you you forgot one. This is a homework exercise, so there's no grading. Okay, so guess what? I answered the first one wrong. They give me my answer, the right answer. I can look at the solution, or I can click on the PDF button and get a solution that's printable if I want to print it out and look at it that way. Also, if I'm not sure and I need some additional help, I can go here and they have a variety, depending on what topic you're doing, you can have a variety of support services here. And you can try another practice set and do it all over again. So I think that's quite remarkable. And then the last thing I want to do is show you that it is compatible with your iPhone. maybe. Now it worked. It worked before in the ready room. Do you know why it's not working? Oh, now it's up there. It was up there, it's just not here. Okay. So let's go to one of those ones we looked at before. There we go. Have to hit it right. It looks like something you've seen before, but look how nicely it comes up on my, this is an iPhone. It works on Androids as well. And this is the same example we saw before. And we can see another example and another example and another example. So these links I have here are just like the ones I had in the presentation. Okay? All right, so that's it. Any questions?
Are you, the pricing of this is going to just be incorporated into student tuition?
No, the pricing is instead of buying a textbook at $150, the students will pay $55 and they'll get the text, the modules, which they can just use online or they can print off if they want to. They'll get the homework, which was what we were looking at a minute ago, and we'll get the quizzes and tests for $55 instead of $150. And it's paper-free. It's not that heavy textbook that they have to carry around in their backpack, and if they want to, they can print the modules out, but they don't have to. So we have a price reduction, we have irritated publishers, and we have, well, we're going to actually have to develop a weightlifting plan at the gym. So, but which is fine. You know, if I can do CrossFit, you can too. Anything? Yes, sir. The programmers are writing the questions, both for the physics and the algebra course from Ryerson in Toronto, and from this here. And we consult together, but they do all the coding. They send me problems, and I tell them, no, that's not quite right, or yeah, that's perfect. Okie dokie. Thank you.